Hi everyone. Over time, I've had an incredible amount of requests to build a custom vacuum tube audio amplifier, and that's what we're going to do. I'm going to take you through my entire thought process as I'm putting a vacuum tube amplifier into this. Just grab this right here. Into this right here. Now, this was very reasonably priced. This was only $60. And they did a really nice job putting this together. The Tolex looks really nice. It has miniature chicken head knobs. The plate underneath here that has all of the writing on it looks like it can be removed and customized, which is very important. So probably by removing all of the chicken head knobs and removing all the retaining nuts for the VRs and stuff like that, maybe this switch, remove this plate here and customize a new plate and put it on. That would be really, really neat. Nice job on the grill. Now, when I'm going to purchase something like this, there's a whole bunch of things I am looking for. Those are a bunch of them there. But really, when you're going to create something, I look at this as pretty much a blank canvas. Where am I going to start? How am I going to make this all work? There's a whole bunch of things going through my mind at that time. I want to share all of these thoughts with you so you can carry this through into some of your own projects. And this thought process can be used for many different things, not only audio amplifiers, but for RF amps and things like that as well. So, since this thing is somewhat of a blank canvas, I'm thinking to myself, okay, I saw this, I'm thinking this would make a really neat little vacuum tube amplifier. Now, what about the chassis inside? Because that's the most important part. You know, we have to mount transformers and vacuum tubes and things like that to a chassis in here. What really is inside this thing? So when I turned this around, to my surprise, look at this. I'll just get the paperwork and all the stuff out of here from when it was purchased. Look at that chassis. That's begging for a vacuum tube audio amplifier. Look at all that space in there. Now, of course, anything that's built modern like this is going to have some form of a circuit board in it. They're not going to be able to build this point to point for that price point whatsoever. So if we look at the face of the thing again, we can see that there's a bunch of chicken head knobs on here. So chances are the VRs behind that are going to be fastened to some form of a circuit board. Now we can see that wiring is entering here, and I can see a bunch of screws here. And there's two right here, so chances are that is a power transformer or something. So there's probably a certain amount of area in here that has been used up by that circuit board. Now here's the nice thing about taking something like this and converting it. You don't need to rip all the existing circuitry out. If this is designed well, you can use all of this in the preamplifier stage, and then for the output stage, you can add yourself a vacuum tube audio amplifier. You can put push-pull output, single-ended, anything you really want. Again, this thing is like a blank canvas. So what I'm going to do is I'm going to share all of the thought process when I'm removing parts and pieces out of this, where we're going to pick audio signals off, how we're going to feed that into, say, a phase inverter, and what kind of a drive level we need, and all that kind of stuff, that entire process. And believe it or not, it really is quite simple. It's very simple to take something like this and convert it into something really, really neat. Now, I don't want this to be like an everyday conversion using 6V6 or a 6BQ5, all of those tubes have been used over and over and over again, and really when it comes down to it, it's kind of like yawn, boring. So I have a really neat tube that I displayed in video number 3. So if you go into the list of videos, that will be linked right underneath the video description here. Click on that link and check out video number 3. I built a small audio amplifier with a tube, the number 6360. Very neat little tube. It's basically 2 tetrodes in one small package. So it's a 9-pin tube that you can make a push-pull amplifier out of with that one tube. You don't need to have 2 separate tubes to make a push-pull amp. And then we'll figure out a really neat phase inverter and stuff like that. So this will be a really interesting little journey for us to go through and see how well this thing lays out and build something neat on this blank canvas that we see right here. So the next thing that I want to do is I want to get this thing out of the case, and I want to see what's inside, because you want to know something? I know as much as you do right now. I just pulled this stuff out of the case. I bought this. It's sit on the shelf here for just a little while, and I want to share this entire experience with all of you. So this should be a really fun build. And then what we're going to do in the future is we're going to grow on this. So now we're starting with something simple, maybe, as I say, that 6360 and a small phase inverter of some sort, and then we'll grow into larger tubes, maybe some big power tubes, 6V6s, maybe move up to 6L6s, who knows, 8417s, whatever. We'll keep moving up. We'll keep moving up and build a really large amplifier eventually, so for those of you that want to build one. I showed in another video here those big Bogen amplifiers that were basically used as parts, and I've got chassis with transformers in them. So that is going to be a really nice build. I'm going to build a really nice amplifier with those, and I'll share that experience with you as well, my entire thought process. So what I'm going to do is I'm going to remove this thing from the bench here. I'm going to go into the other bench and somewhere I can get a better view of the chassis and share that all with you. And we'll take a look at the chassis, how they've put this thing together, and what we're up against underneath this piece of metal right here. All right, let's open this thing up and see what's inside. So the first thing I need to do would be remove these speaker wires. And I think that's about it for that. So what I'll do is remove these top screws. So what I'll do is I will remove the front ones first. Interesting, self-tapping screw. Pretty long self-tapping screw. There we go. Move that out of the way. I do have to say, this thing really does look like it's put together well. And the handle and everything, it looks really good. Okay, so there's this one here, and I think once I undo the last one, this little chassis will probably start to come out. Most of the amplifiers, there is a chance that these are holding it in as well. We'll find out, right? But most of the amplifiers are just held like this. So I'll just hold this up tight just in case. I don't want that falling down. With tube amplifiers, it's a different story. A lot of the times you get really heavy transformers on them, especially the big fenders. So a lot of the times it is a good idea to have the unit on its side or something like that. That will tend to favor the weight. There it is. Just like so. That came out really easy. Just move this out of the way. And look at that. That's a nice clean build. So what I'll do is I'll just zoom on into this. Like so. Wow, that's really nice and clean. And look at all this area here. That's a lot of area. All this area here. Lots of room to... It's even a hole kind of pre-drilled here. You can almost use that to, just drill that out a little bit larger and use that as a tube socket. I'll just move this back here. So it looks like it stops about, well, if we look here, so it's just a little bit above that screw. So it's the PC board actually stops right about here. So that's a lot of room. So I think this is going to work out very well. A little power transformer over here in the corner. So when I search out a power transformer for this, and of course audio transformer and all that stuff, I'll see if, what does this say here? It says output 14 volts times 2. So that's obviously center tap, so it'd be 28 volts, so 14,014 most likely. So they've most likely done that. It says op amps in here. It looks like there's op amps and things in here, so possibly positive and negative supply. We'll have to get into all that And there's the output chip. What are they using? What is the output? I'll zoom back in here. Get that a little closer. TDA 2030. That's a nice little audio IC. ST, good brand. Wow, it looks like they've done a really nice job with this. The pots are mounted to the board so nicely. I do have to say, you know, for the amount of money that was paid for this thing is very well built. I wasn't expecting anything like this. You know, I was expecting a little circuit board, maybe a circuit board here that holds all of these and a bunch of wires running off, or, you know, something like that, a ribbon wire that runs off to another little small board. But this is very well built. It's kind of impressive. Is the plastic edge lit? Looks like they've edge lit the plastic. Well, let's find out. Just undo this twist tie right here. And probably have to turn out some lights for this, I imagine. And let's see this one here. It's going to get kind of dark. All right, let's see how this looks. That's kind of neat. They've actually edge lit the plastic, it looks like. Oh, look at that. Isn't that nice? Cover these up. I can see what they've done is they've drilled the hole in the plastic here is to light the numbers. That is really nice. Boy, does that ever leave a lot of possibilities. Can change the little surface mount LEDs to a different color. You know, if I really wanted to go crazy with this thing, I could even use, you know, maybe even some form of a blacklight LED and then have the numbers in a kind of a neon color so that it would light it all up. So there's, you know, there's endless possibilities. This looks really good the way it is. Like, I mean, that's very white. Kind of looks blue in the camera, but that's very white. As to tap the white balance on the camera, that would come out being, you know, very, very white looking. It's a cold white color. These kind of look blue, as I say, but it is very cold white. So very nice. Wow. So it looks like we're off to a good start. I'll just unplug this here. See the capacitors discharged there as the lights went out. Let's turn everything back on. So it looks like this one here. Get that one on. So it looks like we really are off to a good start. About the tackiest thing in this thing is a piece of masking tape. That's about it. Everything else is very well done. Oh, and that reminds me, I wonder... Yeah, that's just either stuck on there or it's just a sheet of something, piece of plastic that's, you know, has all of this written on it. So that could very easily be changed as well. So lots of great possibilities with this thing. What I'm going to do is I'm going to go get a better lens. I shouldn't say a better lens, just a different lens. And we'll zoom right down in on the circuit board and we'll take a look at some of these ICs and see what they've put in here for the ICs and the components and check out their soldering. Let's check out the build quality of this little amplifier. Already, it's looking pretty impressive. So what do I see? Well, I see very nice soldering, so the machine was set up nicely that soldered this. Look at all the stitching in the ground planes. Stitching everywhere. Ground planes are stitched together. Look at all that stitching over there. What does that tell me? The person that designed this, even this right here is telltale of RF work. The fella that designed this, or the lady that designed this, whoever, he or she, has been working in the RF industry. As I've said in many of my other videos, once you understand the RF world, working on audio stuff is all that much more easy, and it makes all that much more sense. So chances are the person that owns this company hired an RF engineer, and they knew what they were getting, and the RF engineer is the person that designed this. So he or she did a very, very nice job, whoever did this. PT2399, that is an Echo IC. So that's going to give us our effects. PT, I believe, is Phoenix Technology. It's been a while. Phoenix Technology, PTC, Phoenix Technology Corporation, 2399. Neat little IC right there. Very neat little IC. JRC 4558, dual op amp. Another one here, 4558, 4558. So nice, simple design. Very clean. You know, it's nice to see this. You know, so many times you open up pieces of equipment and they just look like crap. This is very nice to see. It's very refreshing. So this is a 78L05. So that's a little 5-volt regulator right there, U6. And the bean counters were in here. So we have to include them too, you know. So HonCon. Yeah. Let's see, what are these? Looks like Chang capacitors. So all of those are going to get the boot. Very nice job. Potentiometers on the front. Everything is just put together so nice in this, you know. It is refreshing to see this. You know, I've opened up so many pieces of equipment. I'll just zoom on out. So I've opened up so many pieces of equipment, and you just look at the design, especially in RF work and things like that, and you're just going, oh man, this thing runs. Well, for example, you remember the FT1000 video on that relay board. Things like that. And then you look at this, and you see an audio engineer designing something like it's going to be used in RF service. Like, this looks like strip line, and it's all over the place. Like, look at these. So they've done a really nice job shielding the traces and things like that. And this is, of course, is going to be stitched to a ground plane on the other side of the board, right? So very, very nice job, whoever put this together. You know, and for the price that was paid for this, it's really quite surprising. So if you want to follow along with this thing and you want to get one of these things, the model number is KU28, and this is just recent. So, you know, looking at the date of the video, this is just recent. I purchased this a couple weeks ago. Oddly enough, it says 2014-05 as a manufacturing date, so it took some time to hit the shelves, I guess. But they're pretty common, it seems. So, and a very, very nice build, and it is such a nice platform to build a vacuum tube amplifier on. So lots of room. So things that are going to have to be done in the next video here are, I'm going to have to remove this, and I'm going to have to put some standoffs under the board because they're using the heatsink here to hold the back end of the board steady. You can see that. So these will have to be moved up here, which in turn will give us more room again. So it gets this out of here. So this audio output IC is going to go because we don't need it because we're replacing the solid state audio output IC with vacuum tubes, which is very beneficial on a guitar amplifier because you get rid of that harsh breakup and you get that really nice soft distortion. So before I remove this, I'm going to give you an example of what I mean. We're going to take a look at how many watts this actually makes. That should be a lot of fun, see if it actually makes 15 watts. Is it 15 clean watts or is it 15 dirty watts? So we'll find out. So we'll see what happens there. And then we'll take a look, we'll drive it right into distortion, and I'll show you what it looks like in distortion. And then once the vacuum tube audio amplifier is made, we'll drive that into distortion, and you'll see how much softer that is. And that's what, you know, the guitar players, you know, any musician that uses one of these amps likes to have when they, you know, drive it hard. They want that softer distortion. And that can all be tailored even more by having the power supply collapse. So that's why in a lot of these guitar amplifiers, you see vacuum tube rectifiers. They're soft, right? There's a lot of drop across them. So you get a really nice soft kind of crash in the audio output section when it's driven hard. So there's a lot of ways you can really tailor the way that these things sound. Most musicians that I find really like that vacuum tube distortion. They really like that soft. Now there are some, you know, hard rock guys that really, really like, you know, the hard breakup or the hard distortion of a solid state device, and this would definitely give that. But, you know, I find the majority really seem to like the breakup and the distortion in a vacuum tube output section. So this should be a lot of fun, especially with that very unique audio output tube, or it's not really an audio output tube, it's basically a dual tetrode. It's used in RF service. and can be used as a modulator or, an audio amplifier. And in this case, we're going to be using it as an audio amp. So what we're going to do in the next video is we're going to follow the signal through here, and we'll also remove this IC after we, make all of these measurements here, and I'll tap where the audio output, where the output section here goes into this IC here. So basically I'm going to tap the input to the output IC. That was a good way of putting it. And then that will run out to the phase inverter, and then that phase inverter will run off to the, to the audio output tube that we're going to use. Now this power transformer here is really, really big for this amplifier without this audio output IC here, right? This is so big because it has to deliver, needs to have power delivering capability to drive that 4-ohm speaker. So this could even be downsized just to power up this board, because all it's really doing is powering up a preamp. Now I may be able to remove this. I might replace this just with one big transformer on the upper side of the chassis. Or I might just leave this in here and just bolt a B+ transformer on the upper side of the chassis, and then on this end is where the audio output transformer would have to go, because you need them far away from each other so that they don't couple. And a lot of the times you don't want them both sitting like this, you want one sitting like this as well, just to keep that hum down. Now imagine the design of this amplifier here probably is already a very low hum design, the way that they've done the trace stitching there and all that stuff. As I say, the engineer that did this job, the company that hired the engineer to do this job most likely targeted an RF engineer and then made him design an audio board, and that way he's really getting, or she's getting, whoever is getting their money's worth when they're designing this thing, because you have that RF engineer knowledge going into this thing. And as I've mentioned in many of my other videos, once you understand how RF works and travels on boards and in circuitry and things like that, understanding audio amplifiers and all that stuff is just all that much easier. It really is. So again, I'll go into more of that into detail here in the future as well. There's just so many things to share. So lots of really neat stuff coming in the next video here. So I'll get lots of stuff prepared for that next video here, and we'll start checking out this little circuit board. Who knows, maybe even change the color of the LEDs in the end and things like that. So this should be a really fun build. If you have any ideas or suggestions for this build, something that you would like to see, leave it in the comments below, and if it's valid, I'll add it to the design. So as I say, any comments or suggestions are always welcome, and I'll see you all very soon. If you're enjoying this, you can let me know by tapping the heart symbol below. This is part 1. Part 2 will be coming very shortly. And we'll start constructing this very unique little vacuum tube audio amplifier. Bye for now.